In this simple mechanical system, the small gear rotation drives the T-section, and the T-section drives the rotation of the small arm at the top of the model. We are going to employ some mathematics to calculate the angular velocity and angular acceleration of this arm at specific moment. To make things easier, we are going to give each element a distinct color. Track the arrows to have a clear idea of how these elements move together. We can see that blue and red parts do rotation, while the green part does a linear displacement. Notice how the green T section moves up and pushes the red arm, forcing it to rotate. We can see that the 8 cm radius blue gear has a physical contact with the green T section. The green T section has a physical contact with the red arm. We will start with the one that drives the motion, the blue gear. Knowing that at the moment the red arm makes a 20 degrees angle with the vertical. The blue gear rotates at 3 rads per second and accelerates at 8 rads per second squared. We are going to find the angular velocity and angular acceleration of the red arm. First thing we need is to find the linear velocity and linear acceleration of the rim of the blue gear. Notice how the blue arrows follow the tangent of the circle of the gear. Notice that at the contact point, both parts share the same speed and same acceleration. At this stage we know the velocity and acceleration of the green T section. By looking at 3 different cases, we can see how the green part will rotate the red part when it moves up. So we can employ some triangular formulas that we know from mathematics. By comparing the lengths of x and y in the 3 graphs, we can see that y decreases but x increases. Now comes the mathematics parts. We start by building the sine and cosine formulas of the triangle. Notice that we don't have information about x, so we are not going to work with the sine formula. Having the cosine formula, we differentiate with respect to time. Knowing that the time rate of change of y is equal to the velocity of the T section as it moves up, and the time rate of change of the angle is equal to the angular velocity of the red arm. Applying the values in the equation, we can calculate the angular velocity. Notice that velocity was taken as negative value as the length of y is decreasing over time. Now having the second derivative with respect to time. Notice that the second derivative of y represents the acceleration of the green section, which will also be taken as negative value. And the second derivative of the angle represents the angular acceleration of the red arm. Applying all the values in the equation, we can find the angular acceleration of the red arm. The idea of this example was to show you how to analyze a model that consisting of many parts, and how these parts interact with each other to transfer motion between them. And also to show you how mathematics can be employed to solve such problems. Thank you for watching.